मंगल किया पर इंसान
Yes. So it's time to start. Hi, myself Anil Kumar Sahu, and basically I'm from Odisha, Bhubaneswar, Odisha, and in the retention time, I completed your determinant and matrix portion also. Okay, so uh, actually previously I was not well, that's why Trivendu sir was taking your classes. And in the last two classes, Trivendu sir was continuing the function and with the inverse trigonometric functions also. And he was continuing the portion that is you have already covered in class 11th, right? Yes. Is my voice clearly audible to you all, guys? Can you please respond in the chat box if it is clear to all? Yes, it is clear, I hope. Okay. No issues. So when you are having any doubt when I am teaching, when I am teaching, if you have any doubt, you can write your chat box write your doubt in the chat box. Yes. So in this class, we'll continue from that when Trivendu sir, where Trivendu sir was left the portions. From there only we'll start our classes. So Trivendu sir was continuing the standard functions, right? Okay. So chalo. So we'll continue from that only. Okay. So all these bluish portions have completed by Trivendu sir. Yes. All these bluish portions have completed by Trivendu sir. Okay. So first, identity functions, constant functions, polynomial functions, rational functions, exponential function, logarithm function, modulus function, and signum functions. All these standard functions have completed by Trivendu sir, right? Yes. So I hope all of you have very much clear about all these functions. When required, when we'll solve some questions, when required, I'll ask and you have to answer definitely. Okay. So we'll left with two important functions, two important more standard functions. One is greatest integer function and another one is the very much important, that is fractional part function. So these two functions are very important functions also, and you must have to understand these two functions very clearly. Okay, so let's start with greatest integer function. So definition is in our screen. No need to go through the definition, just I'm explaining, you have to listen this. Okay, so let's see. Greatest integer function is denoted by this: f of x is equal to box of x, or you can read it as greatest integer of x. Okay, f of x is equal to greatest integer of x, you can read. Okay, so simply what is this? Okay, so if we take any real number, and I will ask you to find what is the greatest integer of that real number. So how you can find, that is important, right? So the definition says, if with the example, suppose I am taking the first example, that is 5.32. I am taking x as 5.32, right? Okay, and I am asking to find greatest integer of 5.32, right? Greatest integer of 5.32. So what is the answer? What is the answer? Answer is on your screen. No issues. Really, how you are getting 5, right? That is important. Okay. So listen to me. The integer, the greatest integer, which is less than or equal to x. What is x here? X is 5.32. Okay. The integer, the greatest integer, right? Not the integer, greatest integer, which is less than or equal to x. That is the value of this greatest integer of 5.32. So if we'll see the number line where 5.32 will be lying, that is important. 5.32. Suppose here 5.32 is the line, right? So now tell me, now mark or plot the point or the number, the greatest integer which is less than, the greatest integer which is less than 5.32 or equal to, either it could be less than or equal to. In case of integer, when you will when we'll take any integer, in that case we'll take that number only. But when we are taking any fractional number, suppose here I am taking 5.32, the greatest integer which is less than or equal to 5.32, that is actually the definition saying. Okay, so here we can say, or we can see here, 5 is the greatest integer. 5 is the greatest integer. सबसे बड़ा integer जो है, that is 5, which is less than 5.32. So simply we can say the greatest integer value of 5.32 is 5. Is that clear to everyone, guys? Is that clear? Yes. So we'll take another case when equality comes. That is important also. Okay. Suppose I am taking x as 5. Let x as 5 I am taking. So greatest integer value of x. What is greatest integer value of x? So 5 is here. You can say, you can see here, 5 is here. The greatest integer which is less than or equal to. So it's a 5 itself is a integer. Itself an integer. Okay. So we can say we need not to go through any lesser than integer or which is less than 5. Go through any lesser than integer. Okay. So we can say in case of 5 is the greatest integer value of 5. 5 is the greatest integer value of 5. Yes, because it is equal to 5. Either it is less than the greatest integer which is less than or equal to 5. Okay, so in case of, if we take negative number, suppose I'm taking here minus 5.32, right? So minus 5.32 here, suppose it is lying here, minus 5.32, right? And this number is 6, right? So now tell me, what is the greatest integer value of minus 5.32? The greatest integer which is less than minus 5. The greatest integer which is less than minus 5, less than minus 5.32 or equal to minus 5.32. So here the number, the integer, the greatest integer 6 is present, which is less than minus 5.32. So greatest integer of minus 5.32 is minus 6, right? This number is, sorry, minus 6. Is that clear to everyone, guys? If it is clear, please respond to the chat box, everyone. If it is clear to all. Yes. Can you please respond to the chat box if it is clear to all? Similarly, you can take negative, greatest integer of negative 5, right? Greatest integer of negative 5 is negative 5. When you are taking greatest integer of any integer, that integer will come. Okay. When you are taking any other number, fractional or you can say irrational number also, here you can see we are taking greatest integer value of root 2, right? So what is the value of root 2? Root 2 is 1.414 approximately, right? So greatest integer of 1.414 is the greatest 1.414. Suppose this number is 1.414, right? So what is the number which is, what is the greatest integer which is less than or equal to 1.414? That is 1. Okay, that is 1. Okay. Simply also another irrational number we can take pi. Okay, so pi, value of pi is 3.141, right? 3.1, approximately 1.341 we are taking. So if we'll take the greatest integer of this irrational number, is this fractional number, we can say irrational number, right? So we are taking the approximate value. Okay, so 3.141. This number is 3.141. So the greatest integer which is less than 3.141. In this case, we will take the greatest integer which is less than 3.141. So greatest integer is 3. and which is less than 3.141. So the value of this greatest integer value of 3.141 is 3. Is that clear to everyone, guys? Clear? Okay. Similarly, here in the last example, we have taken the Euler's number, that is E. So we know the value of E is 2.718, approximately 2.718. It will take the greatest integer of this number, 2.718. Suppose this number is lying here, 2.718, right? So what is the greatest integer which is less than or equal to 2.718? Oh, that is here negative we have, na? Sorry. Minus 2.718. Here we have to take minus 2.718, right? So what is the greatest integer which is less than or equal to minus 2.718? That is minus 3. Yes, so the answer is minus 3. I hope this is clear to everyone, guys. Clear? Greatest integer is denoted by this greatest integer value of x. You can read it as like this, or you can take you can say also box of x. Yes. JNV Nelo not 6. Yes. Thank you. JNV Nelo. Already I have rectified that one. Okay. Okay. So this is all about your greatest integer function. Now we'll go through the graph of greatest integer function, right? How we can draw the graph of greatest integer function, that is important. I think, or I hope in class 11th you have a lot of experience with drawing the graph, right? So how we can draw the graph? We'll take the values of x and we'll get the values of y, and we'll plot all those numbers, or we'll plot what are the outputs you will get. You have to plot all those things on the graph, and then you have to join. Then what is the graph? What is the figure you will get? That is the graph of the given function. That is important. Yes, I hope this is clear. I hope, or I think all of you have a little bit of experience of drawing graph, right? Because you have completed 11th. Yes. So in this case, our function is y is equal to greatest integer of x, right? So I'll take another color. Let's take black color. Okay. So see, I'm taking first the value of x in between 0 to 1. See here, this interval I am taking the value of x in between 0 to 1, where 0 is included and 1 is excluded. 0 is included means you can see here on your screen, it is written as 0 is less than equal to x less than 1, right? That means 0 is included. Sorry. Yes or no? So when x is belongs to 0 to 1 and 0 is included and 1 is excluded, right? 0 is included and 1 is excluded. So 1 is excluded, that means I have to give one hollow circle here, because it is not included with the graph, right? And 0 is included, and in between 0 to 1, excluding 1 and including 0, and all this number I have taken. So in between 0 to 1, if you take any number, any real number you will take, suppose you will take 0, so greatest integer of 0 is 0. If you will take 0.12, this will give you also 0. That means you are taking x is 0, x is 0.12. What you are getting? The value of y. Yes, the value of y you are getting, right? If you will take 0.57, this will give you 0 also. And this value 0 is y, the value of y, right? So in all these cases, when 1 is excluded and 0 is included, we are getting y is equal to 0, right? So how the graph of y is equal to 0? It's a line and it's lying on the x-axis. Y is equal to 0 means it's x-axis, but you have the restriction x is lying between 0 to 1, when 0 is included and 1 is excluded. Is that clear to everyone? So y is equal to 0, that is this line. Y is equal to 0, that is this line. Is that clear to everyone? This line is y is equal to 0. I hope this is clear to everyone. Next we'll go through, if we'll take, suppose I am taking now x is lying between 1 to 2. I'm taking now x is lying between 1 to 2 and where 1 is included and 2 is excluded, right? 1 is included and 2 is excluded. Sorry. What I have said, one thing. We have taken the values of x in the first case. We have taken the values of x in between 0 to 1 when 1 is excluded and 0 is included. What we are getting? We are getting y is equal to 0. Is that clear? Right. Clear. Okay. And in the second case, what you are taking? You are taking the values of x in between 1 to 2, where 1 is included. See here, where 1 is included and 2 is excluded. That's why I'm taking a hollow circle here. Is that clear to everyone? And when you are taking any real number in between 1 to 2, suppose I'm taking 1.4, greatest integer of 1.4 is 1, right? Greatest integer of 1.9 is 1. Greatest integer of 1 is 1. That means we are getting y is equal to always 1. When x belongs to 1 to 2, where when 1 is included and 2 is excluded, we are getting the value of y is 1. That means y is equal to 1. The graph of y is equal to 1. All of you know what is the graph, how you can draw the graph of constant function. Here y is equal to 1 is a constant function, but for the domain x, you have the restriction. X must be lying between 1 to 2 and 1 is included and 2 is excluded, right? And you are getting the output as y is equal to 1, right? Similarly, if we take when x is belongs to 2 to 3, right? When 2 is included and 3 is excluded, clear? 2 is included and 3 is excluded, and in between 2 to 3, if you will take any real number, suppose I am taking 2.999. So what is the greatest integer of 2.999? That is 2. Yes. So in this case, we will get y is equal to 2. The graph will be y is equal to 2. In this way, you can draw the graph of greatest integer function. Clear, everyone? Yes. So if we will take, suppose now, already we have seen some examples of positive intervals. When x we are taking the values of x, we are taking the positive interval. Now we'll take some negative intervals, right? When x belongs to -1 to 0, I'm taking right now, I'm taking x belongs to -1 to 0 and -1 is included. See here, -1 is included and 0 is excluded. And in between -1 to 0, if we take any real number, suppose I'm taking -0.67. So the greatest integer which is less than or equal to -0.67 is -1, right? So the graph of y is equal to -1 is like this. So this is the graph of y is equal to -1. Clear, everyone? Yes. I hope this is clear. Similarly, if we take -2 to 1, -2, x belongs to -2 to 1, -1, right? And -2 is included and -1 is excluded, right? And we are getting, when you are taking the values of x as in between -2 to -1, when -1 is excluded and -2 is included, you are getting y is equal to -2. Okay. So I hope the graph of greatest integer function is clear to everyone. If it is clear, please write in the chat box, YouTube guys and also the Zoom guys, please write in the chat box if it is clear to all the graph of greatest integer functions. Now you can draw the graph of, tell me one thing, now you can draw the graph of greatest integer function by your own or not. Let me know in the chat box. If I'll close my screen and I will ask you to find, draw the graph of greatest integer function. So you can draw or not. Let me know in the chat box, everyone, guys. Yes? You can draw or not? Okay. If you have any doubt, you can ask. कोई भी doubt हो तो पूछ सकते हो. Any doubt you have. Any doubt? I'm waiting for your response. Don't worry. When you will ask doubt, na, the class will be interactive. Otherwise, it will be boring to you and also for me. Yes. JNB Nolo, do you have any doubt? If you have any doubt, you can ask. In the graph of greatest integer functions or whatever we have completed or we have covered in this class, do you have any doubt? Anyone is having any doubt? Okay. So now come to the domain and range of greatest integer function. What is domain? What is domain? Anyone can write in the chat box what is domain of a function or what is range of a function. All of you have completed in class 11 and also Trivendu sir, I hope he has also completed this portion. है ना? Guys, graph of one step function. This is the graph of step function. JNB Nolo, this is the graph of step function. Already I have drawn. Do you have any doubt? You can ask. कोई doubt है इसमें? First step function, one by step function. I'm not getting you. Can you ask this clearly? Yeah. So the domain, the domain, the set of all inputs for which the function is defined, right? This is domain. Reciprocal. Graph of, I'm not getting you. One by like this. You will take y is equal to greatest integer of 1 by x, right? You are asking this, y is equal to greatest integer of 1 by x. So simply you have to take the values of x and you will get, when you will put the values of x, you will get the values of y. Likewise, you can plot the graph. Function is exist, the A is domain. Yes, function is defined, right? Yes, function is exist also, you can say function define हो सकता है. जब function define होता है x की वैल्यू के लिए, जिस x की वैल्यू के लिए function define होती है ना, उसको हम domain कहते हैं. ठीक है ना? ठीक है. The values of all x for which function is defined. That means here in this case, what are the values of x you have taken? And all these, for all these values also, y is defined, function is defined, right? Okay. So all these set of all these values of x is called my domain. So you can see whatever you have taken in place of x, right? So set of all real number you can take. Set of all real number you can take, and for all real number, greatest integer function is defined. Right? That's why the domain of this function is R. Right? Clear? And what is the range? In case of what is range? The set of all outputs, the set of all values of y for which x is defined. Right? This is thoda complicated definition, but simply we can say after putting the values of input or after putting the values of x, what you are getting, that set is called my range set. The set of all outputs, we can say, the set of all values of y, we can say. Okay? So in the right hand side table, what are the values you are getting? That is my range set. Some intervals we have taken in this example or in this graph when we are drawing the graph, but when whatever the real number you will take, you will get, when you are taking the greatest integer of that real number, you are getting the integer only as output, right? That's why the set of all integer is our range set of greatest integer function. Clear, everyone? Range set of greatest integer function is z, the set of all integers. You can say na, y is equal to 0, y is equal to 1, y is equal to 2, y is equal to 3, y is equal to -1, y is equal to -2, all these numbers. are integers or not. So all these numbers are also my outputs after putting the values of inputs x I'm getting. Is that clear? So the range set is Z in this case, and the domain set is R. From the graph also you can observe, hai na? On x-axis we are taking all the real values. On x-axis we can take any real values, right? And x-axis in x-axis, what are the numbers you are taking? That is the range domain set. On y-axis, from where to where graph is going? कहां से कहां तक y axis में ग्राफ जा रहा है बताओ. On y axis, from where to where the graph is going, you can see from minus infinity to infinity. From minus infinity to infinity on y axis the graph is going, right? That is, y axis represents to your range set, and the graph on y axis is represents to your range set, and the graph on x-axis represents to your domain set. You can see, observe the graph, the set of all values of y goes from minus infinity to infinity. Sorry. I'm sorry. On x-axis, the graph is going from minus infinity to infinity, right? Minus infinity to infinity. But on y-axis, the graph is only goes from goes on only integers. Y is equal to 0, y is equal to 1, y is equal to 2, y is equal to 1, minus 1, y is equal to minus 2. Sorry, actually, wrongly I have told this. Okay, so on y-axis, the values of y we are getting, or the graph we are getting, that represents the set of all integers, and on x-axis it goes from minus infinity to infinity. That's why the range is Z and the domain is R. I hope this is clear to everyone, guys. Clear? Greatest integer function ka domain jo hai, the domain is R and the range is set of all integers. Clear, everyone? Yes? Clear? Okay. So let's move to the next thing. Here's some properties of greatest integer functions is given on your screen. You can take a screenshot on your desktop or on your laptop or on your mobile. You can take a screenshot of all these properties of greatest integer functions. To prove all these properties, just put x as any number, x as any real number. You will get the proved properties. Okay, any number, any properties, you have to take one screenshot, because if we'll discuss all these properties one by one, it will take a lot of time, but we don't have any more time, right, to discuss all these things. I suggest to take a screenshot of your screen and try to prove all these properties by your own, right? Let's move to the next important function, that is fractional part function, right? And this is also important standard function and very useful functions also. Fractional part function, and you can understand this function by its name also. It's what is the name of this function? Fractional part function. That means if I'll give any real number to you, right, any real number to you, then you can find the fractional part of that number. Simple. That fractional part you need to find here only, right? So the definition says fractional part function is denoted by, or you can read it as fractional part of x. Fractional part of x. It is this function is denoted by this fractional part of x, and it is defined by x minus greatest integer of x. X minus greatest integer of x. Okay. So simply you can take any real number. Suppose I am taking here 2.5. Fractional fractional part of 2.5, that is x is 2.5. Here I have taken x as 2.5. So x is 2.5. 2.5 minus greatest integer of 2.5. Now you can tell me easily 2.5 minus greatest integer of 2.5 is, can you write in the chat box what is the greatest integer value of 2.5? That is 2, right? So 2.5 minus 2 is 0.5. So this is the fractional part of 2.5. 0.5 is your fractional part of 2.5. I hope this is clear. It's very simple. Yes or no? Sorry. Simple or not? Clear? Okay. Some other number also we can take. Here some other examples we have taken. For some negative number, minus 3 point, fractional part of minus 3.64. So x is, what is the definition? Here x is minus 3.64, right? So definition says fractional part of this number is x minus greatest integer of x, right? So x is minus 3.64 and minus greatest integer of negative of 3.64. So greatest integer value of minus 3.64 is minus 4. Is that yes or no? Is it or not? Yes or no? Minus 3.464 की जो greatest integer value होती है, that is minus 4 or not? Yes, minus 4. So minus 3.64 minus of minus 4, that gives you 0.36. So what is the fractional part of minus 3.64? That is 0.36. Clear? Clear everyone? Similarly here also minus 5. Suppose I am taking here fractional part of 5.2. 5.2 minus greatest integer of 5.2. Greatest integer of 5.2 is 5. So 5.2 minus 5 is 0.2. Clear everyone? Now we'll go through the graph of fractional part function, right? But how we can draw the graph of fractional part function? We'll take the values of x first and we'll get the values of y. So what are the values of x we can take? Any real number we can take. Suppose we are taking 0 point in between 0 to 1. Suppose we are taking any values, any values of x in between 0 to 1, where 0 and 1 are included. We have taken here the values of x in between 0 to 1, right? Any number you can take. 0.9 suppose I am taking. Fractional part of 0.9, that is x is 0.9. So 0.9 minus greatest integer of 0.9. So 0.9 minus 0, greatest integer value of 0.9 is 0. So fractional part of 0.9 is 0.9. So if we'll take 0.4, fractional part of 0.4. So simply we can say 0.4 is fractional part of 0.4. So if we'll plot all these number, if we'll take the values of x in between 0 to 1, and if we'll plot all these number or all these values of y on the graph, I'll plot all these numbers by like this. But always remember, what are the outputs you are getting? It is always lying between, it will be always lying between 0 to 1, where 1 is not included and 0 is included. Yes or no? Fractional part means it should be like between 0 to 1, where 0 is included and 1 is not included. Yes or no? Clear everyone? Clear or not? In case of 0, suppose you can ask, sorry, if you take 0, so fractional part of 0 is 0. If you take 1, the fractional part of 1 is 0 also. Yes or no? Clear? So here you can see the graph goes from, on y-axis the graph goes from here like this. Y is equal to, what is the graph? This x. Y is equal to x. Simply when you are taking the values of x in between 0 to 1, right? Always you are getting the same number. 0.4 ka fractional part 0.4, 0.9 ka fractional part 0.4. So x the fractional part in, when x belongs to 0 to 1, when you are taking the fractional part of x, the fractional part of x itself x. Yes or no? So y is equal to x. This is the graph of y is equal to x. Now if we'll take 1 in between, the values of x in between 1 to 2. Okay, 1 to 2, suppose I'm taking any point, you can take any number, you can take, suppose I'm taking 1.5, fractional part of 1.5. Yes, fractional part of 1.5. So what you are getting the fractional part as 1.5 minus greatest integer of 1.5, that is 1.5 minus 1, 0.5. Hai? So always you are getting the output, the values of outputs in between 0 to 1. Always you are getting the values of y in between 0 to 1. So here in this case, when you are taking the values of y, x in between 1 to 2, you are getting the graph of y as, this is my graph of y is equal to, who can say what is the graph of this line? It is x minus 1 or x plus 1? Anyone can say? What you are getting? Y is equal to, you are getting the same graph, but it shifted on x-axis 1 units right side, to the right side. It is shifting to the right side on x-axis 1 units. So what should be the graph of this line, red line, this red line in between 1 to 2? It is x minus 1, y is equal to x minus 1. It is x minus 1, yes or not? Yes or no? If we take, suppose if you are taking 1, you are getting 0, right? When you are taking 1.5, you are getting 0.5. If when you are taking 1.9, you are getting 0.9. So it is the graph of y is equal to x minus 1. Similarly, this is the graph of y is equal to x plus 1. This is the graph of y is equal to x minus 2. This is the graph of y is equal to x plus 2. Yes or no? Hai na? So always remember the linear function y is equal to x, ax plus by plus c. It is always represents to a line or not? Always a linear function. Always a linear function represents to a line or not? Yes or no? Y is equal to x minus x. It is the line. It is the equation of line which is passing through the origin. Is that clear to everyone, guys? Yes, clear. Okay, very good, JNV Nelo. Very good. That's nice. You are responding. JNV Kolhapur, JNV Gandhinagar, Ashika. Do you have anyone having any doubt in here? So the last portion, now I will ask, what is the domain in this case? What is the domain? That means what are the values of x you are taking and the function is defined. On x-axis, what are the numbers you are taking? All the real numbers you are taking. Yes or no? All the real number, for all real numbers, the given function, fractional part function is defined. That's why the domain is R. And on y-axis, it goes from only 0 to 1, where 1 is excluded and 0 is included. That's why the domain, the range of this function is 0 to 1, where 0 is included and 1 is excluded. Clear, everyone? Clear? This is all about your fractional part function. I hope this is clear to all, guys. Is there any doubt? You can ask. किसी को कुछ भी doubt है तो पूछ सकते हो. No doubt. चलो, let's move to the next thing. That is properties. Same here also. There are some properties for fractional part functions. These properties are important. है ना? All these properties are very important. है ना? When you are adding any integer to any real number and you are taking the fractional part function, you will get the fractional part of x only. है ना? Suppose suppose I am taking x as 5.5. Okay, and fractional part of 5.5. Fractional part of 5.5, and here I any integer I am taking, suppose 2, right? So this will be giving you what? 7.5. So fractional part of 7.5 it is 0.5. Yes or no? 0.5 is fractional part of 5.5. This is fractional part of x. So first property is proved. Similarly, second property, third property, fourth property, fifth property, and sixth property you can prove by your own. Take a screenshot of all these properties of fractional part function, guys. Everyone. So what is the chalo? Now I'm asking one thing. I'm asking one thing, guys. What is the greatest integer function? Suppose I'm asking here greatest integer function. So what is the domain? What is the domain of greatest integer function? Write in the chat box, everyone. What is the domain of the greatest integer function? That is R, right? What is range? Range is Z, set of all integers, right? This is the domain and range of greatest integer function. And if I'll ask you to find the fractional part, domain and range of fractional part function, what is the domain? Domain is R, right? What is range? Range is 0 to 1. 0 is included and 1 is excluded. Graph कैसे होता है बेटा? Roughly we can draw the graph this like this. Yes or no? Like this. This is the graph of greatest integer function. Now what is the graph of fractional part function? Like this. Okay, ठीक है? Okay, now let's move. Okay, let's move to the next thing. Now we'll see some concept upon algebra of a function. Okay, so what are the algebra function? Algebra means addition, subtraction, multiplication, division, all these things. So now we'll see some algebra function and then we'll go through one more thing, that is equality of function, right? So let's start. Algebra functions means, suppose here one function is given which is mapping from x to r. F is mapping from x to r. All of you know or not? What is x here? This is my domain for which function is defined, right? This is my domain. And what is r here? It is codomain, right? It is codomain. And always remember, range is a subset of codomain. Yes or no? Range is a subset of codomain. So here one function is given which is mapping from x to r, and another function is given which is mapping from x to r. So both the functions are having the same domain and same codomain. Okay, so some algebra on functions will work. Okay, so first algebra is saying f plus g of x. F plus g of x. That means here a plus g is a function of x. A plus g is a function of x which can be proved as, or which is equal to the sum of the individual functions, that is f of x plus g of x, right? F of x plus g of x, where x belongs to the domain of the function, right? This is addition of two functions. This is the way how we can add two functions, right? And similarly, subtraction of two functions, f minus g of x can be written as f of x minus g of x. Similarly, in case of multiplication, f into g of x, f into g of x. That means here, f into g is a function of x, which can be derived as f of x product of individuals, f of x into g of x. These are very basic things. So already you have covered in class 11, right? We are just revising all these concepts and we'll start the 12 portions very quickly. Don't worry. Okay. And the very big topic, determinant matrix, already we have completed. And this is also a very big topic, but we don't have more time. So we'll try to cover the important portions of functions which will be useful in your calculus portions. Actually, function is a topic which is very much useful in your calculus, and 60%, 70% of your 12 book is calculus, right? Okay. Limit, continuity, limit is from your class 11 syllabus, it is present, but that is important. That will be very much useful in your competitive examination or also in your board examinations in class 12. So limit is important. Limit, continuity, function. First तो function तुम्हें पढ़ना पड़ेगा, ठीक है? Trigonometry is important. Trigonometry, function, limit, continuity, differentiability, all these things. Integration, application of derivative, है ना? Application of integrations, area under the curve, then differential equation. All these topics are calculus. So always remember who are very much clear on the concept of function, trigonometry, and limit. So they will be hero in calculus, right? Okay. So similarly, the fourth point is saying, if we'll multiply a constant, with function. Suppose here we have multiplied k with the function f, and we are taking this function is one function, k into f is one function, k into f of x. It can be written as, this k can be goes outside, k into f of x. This is constant multiplication of function. Okay. Division, similarly, division f by g of x, which can be written as f of x by g of x, and where g of x is not equal to 0, because if g of x becomes 0, the function will not be defined, because if denominator becomes 0 in a rational function, the function will not be defined. Yes or no? Already you have covered the rational function portion. Yes. Okay. Let's move through one example. Here, f of x is given as x square. Let's choose one more color. Yeah. F of x is x square and g of x is 2x plus 1. Okay. So these are two functions are given, and these functions are defined on the set of non-negative real numbers. Okay. These functions are defined on non-negative real numbers. Anyone can, what is the set of non-negative real numbers? What is the set? Can you represent it? Non-negative real numbers. That means 0 is included here. Yes, 0 is included here. 0 to infinity. Minus infinity to 0. Right? Okay. So this is my domain for these two functions, and you need to find a plus g of x, f minus g. Very easy. Very easy. Okay. A plus g, that is f plus g of x. Simple. X square plus 2x plus 1. है ना? ठीक है. So f minus g of x, that is x square minus of 2x minus 1. है ना? F into x, g of x. Likewise, you can find, है ना? This is x square into 2x plus 1. Right? And also f by g of x. X square by 2x plus 1. But here one thing you need to mention, that is x must not be equal to 1 by 2. Minus 1 by 2. Right? if x becomes minus 1 by 2, this function will not be defined. Clear everyone? This function will not be defined. I hope this is clear. Very simple things we have covered. These are the solutions. Okay, now we'll see when we can say two functions are equal. When we can say two functions are equal, right? So suppose two functions are given to you. One is f, another one is g. So f and g are said to be equal if domain of function f is equal to domain of function g. Second, these 3 points must be satisfied by these two functions. First point is domain of both the functions must be equal. Codomain of both the functions must be equal, or you can say range of both the functions must be equal. Because when we are talking about, when we are saying codomain of both the functions are same, then we can say range will be same. Mostly, yes, no. अगर कोडोमेन सेम हो रहा है तो रेंज सेम हो जाएगा क्या? नो, कोडोमेन anything we can take, right? And third thing, f of x is equal to g of x for every x belongs to their common domain. A simple thing. Okay, let's see one example here. Suppose first function f is mapping from z to z. That is, here z is given as your domain and this z is given as your codomain, right? Codomain. F of x is equal to x square. It is given. Okay, f of x is given as x square, right? And g is another function which is mapping from z to z. Here also both the domain and codomain are same. In both the case, in case of f and g, in both the case domain and codomain are same, right? And the second function is given as mod of square of mod of x, square of mod of x, right? So first we'll see what are the domain of both the functions, right? It is given in the questions also. Z, in this case z is domain, in this case z is domain. But largely we can say, when we are talking about f of x is equal to x square, forget about these things. When we are talking about f of x is equal to x square and domain is not given, okay, so simply we can say here the domain is given z. So domain of this function is R. So for all real values of x, f of x is defined. You can put any real numbers in place of x for which f of x is defined, right? That's why the domain of this function is R, right? What is the range of this function? What is range? Range is 0 to infinity. Range is 0 to infinity where 0 is included, right? Because x square is a function which will always giving you positive values. Okay, always be giving you positive values, or that is, or 0 is included also. Okay, 0 is included. Okay, so that is starting from 0. You can see now the graph of y is equal to x square. It's a parabola, upward facing parabola, right? And it is starting from, on y-axis it is starting from 0 origin, and it goes towards infinity, positive infinity, right? That's why on y-axis the graph goes from 0 to infinity. 0 is included and infinity is excluded. Always infinity is a very large number, infinity is excluded. Okay, so domain is R, range is R in this case. Okay, g of x. G of x is given as square of mod x, right? Square of mod x. In this case also, when you are taking any real number, this function will be defined. In place of x, you can take any real number. The function will be defined. So that's why the domain of this function will be R. And what is range? You can, if you are taking any real number in place of x, you will get the values of y in between 0 to infinity. 0 to infinity. Already the codomains are given as same, domain are same, and also range are same. range are same, right? The value of f of x and g of x are equal for all x belongs to R. Okay, so for all values, for all real values of x, both the functions are equal. We can say now f of x and g of x are two functions, those are equal. Clear everyone, guys? Clear? Here in the question, what are the domain we have considered in the example, right? F is mapping from Z to Z, G is mapping from Z to Z. Here we have taken the domain as ZZ, right? But हम जनरली बात करेंगे तो जो x स्क्वायर फंक्शन होता है उसका डोमेन R होता है एंड रेंज उसका 0 to infinity होता है, 0 इंक्लूडेड. सिमिलरली स्क्वायर ऑफ मॉड x की जो डोमेन होता है दैट इज R एंड रेंज जो होता है 0 to infinity where 0 is included and infinity. Okay, clear everyone? I hope this is clear. Now another example for you, the domain for which the function f of x is equal to 2x square minus 1 and g of x is equal to 1 minus 3x are equal. You need to find the domain for which both the functions are equal. Anyone can say quickly in the chat box because it's time to end your class right now. Anyone can say what is the answer? You have 30 seconds. What is the domain for which both the functions are equal? How we can find? Nothing to do. It's a very simple question. You can do or not? Simple, yaar. ठीक है? Okay, f of x is equal, just do in this way. G of x. That means we are talking about both the functions are equal. Sorry. That means both the functions are equal. We have taken. So 2x square minus 1 is equal 1 minus 3x. Just simplify it, this equation. You will get the values of set of values of x. See, this is the solution. Hai? By equating both the sides, we are getting x equal to minus 2 and 1 by 2. These are the only two values for which both the functions are equal. These are the only two values for which both the functions are equal. You can see here, f of minus 2 is equal to 2 into minus 2 ka square minus 1. That is 2 minus 2 square is 4 into 2, 8 minus 1, that is 7. And g of x is equal to 1 minus 3 into minus of 2. That is 1 plus 6, 7. So you can see f of x is equal to 7, g of x is equal to 7. Similarly for 1 by 2 also you can check. So the set x minus 2, 1 by 2, the set x containing minus 2, 1 by 2, for which both the functions are having the same domain. Clear everyone, guys? Clear? Okay? Clear? I hope this is clear. Very simple question. And from the next question, next class, we'll be solving some questions on domain and range of a function and how we can find the domain and range of a function. And also we'll see some JEE mains questions also we'll take and we'll solve here also. And also we'll learn some rules how we can find the domain and range and some different type of functions also. For some different type of function also we'll learn some rule how to find the domain and range of a function. So that's all for today's class, guys. Thank you all, guys. Bye bye. Take care everyone, guys. Thank you all. We'll meet in the next class, that is on tomorrow's morning 10 a.m. Okay, bye bye. Take care everyone.